Today's problem is add 1 to number. This is on interview bit, 12-week interview preparation kit, week 3. I forget, is this the first problem in week 3? Well, anyway, you can find this problem over there. So pause the video, go to interview bit, try this problem, come back, we'll walk through the solution. This is rated as easy. I've noticed that as we go through their 12-week prep kit, that everything so far has been easy, but the easy problems have been getting harder. Now this easy problem, I don't think it's very hard, but there is a low success rate. So anyway. This is asked at Google, it's asked at Microsoft, maybe asked at a company near you. I mean, this kind of thing, it's a pretty common type of question. It's just adding numbers, but they're not actually numbers. You get them in the form of like a list or an array. All right, given a non-negative number represented as an array of digits, or in our case, we're getting it as a list of digits. Add 1 to the number. That is, increment the number represented by the digits. The digits are stored so that the most significant digit is at the head of the list, meaning left to right, the way numbers would normally be represented. Note, certain things are intentionally left unclear in this question, which you should practice asking the interviewer. For example, for this problem, here are some good questions to ask. And yeah, these are good questions to ask anytime that you get a problem like this, where, as I said, you're working with numbers, but they're not represented as numeric data types. They're represented as something like lists or arrays. So, could you have in the input leading zeros? In other words, is 0, 1, 2, 3 a valid input? And the answer is, for this question, yes. Another question, can the output have leading zeros? Like if 0, 1, 2, 3 is the input, we add 1 and we output 0, 1, 2, 4. And the answer is no. Okay, no leading zeros. Constraints, length of A is between 1 and 10 to the 6th, 1 million. A, the numbers in A will be digits from 0 to 9. First argument, an array or list of digits, output format. Return the array or list of digits after adding 1. For example, if we get 1, 2, 3, we add 1 and we output 1, 2, 4. Is that the only example? Okay. All right. So let's see how this will work. Let's get the size of the input, n, we'll call it n, is the size of the array list. Let me scoot this over so the comments are more visible. Carry, all right. We need really the key to solving the problem is just to handle the carries correctly. So we're going to start out with a carry of 1. And that way we don't have to handle the first addition as a special case. We just handle it as a carry. We're going to carry 1 into the low order digit. All right, starting from the rightmost digit, as we would do in a typical addition, we get a sum of whatever that digit is plus the carry, in this case 1, and we're going to set that digit to sum mod 10. Now, because we're only adding 1, really the only thing it could be is Well, if we add 1, let's take a more generic case and say that in any case where we do this sum, the only thing we can get is either an integer from 0 to 9 or 10. Now, if it's 10, we want to set the digit to 0 and carry 1 into the next digit's place. So set it to sum mod 10 and then figure out if there's a carry. Carry equals sum div 10. Integer division, so sum could be 10 and the carry would be 1. All right, if at any point in our addition the carry becomes 0, then there is no more processing and we just break out of that for loop. Now it's possible that after the loop there's still a carry. That is, we have to go all the way through we have to go through all the digits. Carry is never 0. We never break out of the loop. We just fall out after we've processed all the digits. Really, the only way that can happen is if the number, the input number is all 9s. Okay? We add 1 and we keep getting, 0 carry, 0 carry, 0 carry. We're going to have a carry. So that means we need an extra digit. And we can do that by adding the carry at index 0 of the list. That'll just put a 1 at the head of the list. Now, another possibility is, as in this example here, if we get 0, 1, 2, 3, we add 1, we get 0, 1, 2, 4. We can't return 0, 1, 2, 4. So we have to remove leading zeros, okay, if any. And actually, we have too much here. It's except for the number 0. Yeah. So rethinking that, we don't need it because the number can't be 0. Even if the number was initially 0, we're going to add 1. So the result is never going to be 0. So we don't have to do this check here, making sure that the size is greater than 1, because we can't have a situation where the size is 1 and the number at index 0 is 0. So we could take that out. Okay? Now it's possible that if you go to an interview, you get this problem and you do this, that the interviewer may switch it up on you a little bit and say, let me change the parameters a little bit here, okay? Let's say I'm going to give you a number and I'm going to give you an integer to add to that number. Now it may or may not be 1. In fact, it could be any number from 0 to 9. All right? In that case, you're going to need this because the input number could be 0 and the number to add could also be 0 and you could get 0. You don't want to loop through everything and remove all the zeros and end up with an empty list. So in that case, yes, you have to check the size. For our purposes, we don't need to check the size. Okay? And then return the list. Let's submit, see what happens. All right, good. That's it. Thanks for watching. There are some general principles here that you should keep in mind when you get problems involving numbers that are not represented as numeric data types. You get a number in an array or you get a number in a list. There are principles here that are reusable. If you found this helpful, hit like, subscribe, check out the playlist on screen. You can keep improving your interview skills. Also, the video description and the pinned comment have links to more resources, including a free LeetCode patterns cheat sheet, which in hindsight, I regret calling it the LeetCode patterns cheat sheet. I'm going to rename that in the near future, because the patterns that show up on LeetCode are the same patterns that show up everywhere else. But that is available. You can download it. And that's it. Thanks for watching, and we'll see you next time.